Before I introduce our next speaker, I would like to make a small introduction. Gáspár works as an independent coach, trainer, and test automation expert, focusing on helping teams implementing BDD and spec flow. So please welcome and help me to have a really nice applause for Gáspár Nagy.
Okay, thank you very much, and it's really glad to be here. So many people are very good. I have my slides, perfect. So today I would like to talk about how design patterns or how the concept of design patterns can be applied to test automation or test automation solutions. And as you have heard, basically my main topic is behavior-driven development, but today this talk will not be directly about behavior-driven development, but more about testing. Actually, I started my career where I'm feeling like a developer, but maybe because of BDD and because of other things. In the last 15 years, I was spending quite much time in test automation, and I had a couple of interesting aha moments or something that I wasn't expecting, and basically part of this talk is about that. It's about my journey into test automation. So, how many of you are feeling like developers? So how many? Just raise your hands. Okay, I as expected most of you. Is there any testers here? And it's not a binary question, so maybe you can. Okay, perfect. And probably a couple of others as well. So most of you are developers here. So this is going to be hopefully an easy exercise for that. So raise your hand if you recognize what you see on the slides. Okay, a few hands. Keep your hands up. What do you think now? Okay, a little bit more. Now, you see some names. And we are always there, right? So, yeah, finally, quite many people have recognized this book. Actually, the Design Patterns book is, I think, one of the most influential books in software development. It was done in 1994, and it's so famous that even the authors got a special name. People are calling them Gang of Four, or even abbreviating that GOF or GOF. Typically in company spaces, people just call it the GOF book or something like that. So I think it's a very important book, and it's about the design patterns. But actually, the concept of design patterns wasn't started with this book. The first mention of the concept was by Christopher Alexander in 1977, so quite early. But definitely this book was the one that brought in this topic to the public. And nowadays, I think nearly every software developer knows about the patterns that are described in this book, like a visitor, a builder, abstract factory, and many others. So I think that's a very important book. And basically, in my talk, I would like to see how the concept of that could be applied to test automation. So basically, these will be the topics that I would like to talk about today. So I will spend a little bit more time on the design patterns, but most of you anyway know that, but why design patterns are useful. Then I would like to talk a little bit about what are the challenges, the typical hard things with test automation, at least the ones that I have seen. And then I would like to talk a little bit about why design patterns might make sense, or why we should better use design patterns for test automation. And in the last two sections, basically, I would like to talk a little bit about some mechanical details or some other details about how design patterns look like in test automation code or test automation solutions. So that's what we are going to do today. So, as I said, the concept of design patterns was introduced by Christopher Alexander in 1977, and he was using these words, or he was borrowing these words from architecture. In architecture, you cannot really figure out the things for every single house you design, because that would take too much time. So typically there are some patterns, some well-known structures, maybe layering or something else, that everyone knows that works. So if you are a designer, if you are an architect, then you can just pick those things, and you can be sure that your house will work as you expected. So this is the idea where the concept of design patterns was also taken about. in software development, we also see some patterns that seem to be working, that are somehow proven, and these are the patterns that we can reuse to be able to have some benefits. Even though that this comes from the architecture and it looks about patterns that you are recognizing, but typically when you use design patterns, it's not the recognition part which is the important, because typically you anyway read the Gov book and you know many of these anyway. And the more important thing is how you are applying that. So I think the kind of definition of design patterns is something like a generic solution or a solution for a generic problem in a given context. So that's what we are using. So whenever we are working with design patterns, I was trying to find another metaphor from cooking. Maybe you can think about that like a special method in cooking. I was choosing the flambe as an example, maybe not the best example, but if you are a good cook and if you know how to do flambe, then basically you can faster produce the kind of taste that you wanted to have that. So it's a kind of method that makes sense to learn because you can better or faster produce the results that you would like to have. So that's how we usually see the patterns. And I think if you think about why using design patterns is beneficial for us, I think this is a pretty much consensus on that. I was taking 3 different aspects of that. Typically people say, and I think that these are all true, that if you are using design patterns, then altogether your code will be better because you are using a technique that has been already proven. Everyone knows that works, so basically you can reduce the chance of issues if you reuse an existing pattern. So that's one thing. Because you don't have to think about, you don't have to invent the solution yourself, obviously you will be able to produce the result faster. And last but not least, and this is also very important for the design patterns, that design patterns are providing you some sort of communication platform. So if you are my colleague and if I just say that, hey, I did that with a builder, then you immediately know what I'm talking about. I don't have to detail the thing about that. So I think these are the 3 key points where the design patterns are help. So with other words, you can say that this is a kind of best practices, so to say. So these are the design patterns that we typically use for software development, but let's see how the thing is different with test automation. And as I said, I started my career as a software developer, and actually when I started, I was in that kind of culture that software development is the thing, and maybe testing is something that you, at the end, do, or it's a simple scripting task that anyone can do if you are talking about test automation. But it turned out that it's not really like that, and there are a couple of interesting moments that I have learned through these years about test automation. And one of the things, and maybe these things are sounding trivial, but sometimes it makes sense to think a little bit behind those things. So one thing that we could consider is that we would like to make better tests or more quality test solutions, and why this would be interesting. And quality and software quality is anyway a very interesting topic. It's something that is very hard to define what makes a quality software, right? So it's hard to measure and how to find some exact criteria for that. And it's maybe even harder for test automation code. So how to decide whether a tester or test automation is good quality, that's a hard thing to do. Some people use for measuring test quality the number of errors that the test is code, but of course, this is not a good measure because maybe the best test that was never finding any bug because it was preventing those bugs because people were using them upfront. So unfortunately, there is no easy measure for that, how we can define software quality. So just to illustrate that, I thought that imagine 3 cars that are more or less the same. Okay, the first one, which is actually the cheapest one, has an engine, like every car, but it doesn't have any engine control. So basically, you have to trust your senses whether the engine is still operating correctly and stop the car if you see some strange noise, right? The middle one is a little bit more expensive. It has an engine control. However, this engine control is sometimes lightening up if there is no problem with the engine, and sometimes it's remaining unsignaled even though the engine is wrong. Okay, so it's an unreliable controlling system. And the third one would be the most expensive, which has a proper engine control, which really only signals if there is really a problem with your engine. So these are the three cars. You are the dealer. You will need to think about which one you would like to buy. Okay, think about that. It's not necessarily an easy choice, especially not an easy choice between the first and the third one, right? Because you would say that, oh, I trust my senses and I'm just spending less money, or, well, I have enough money and I don't want to deal with listening to the engine and I just spend more money. That's basically a kind of dilemma or something problem that we have in testing. Are we trusting ourselves and we don't have so much tests, or we would like to have more tests so that we can be more confident about the quality of the things. So I think it's a hard choice between the first and the third one, and I wouldn't be able to tell you what is the good answer for that, but I'm pretty sure that no one would really buy the second one, right? Because this is more expensive, and anyway, the engine control is unreliable, right? So this is about testing, and that means, if I would like to oversimplify that having no tests is maybe even better than having wrong tests, right? So that's or with other words, we could say that only good tests make sense. So making wrong tests doesn't make any sense because it's cost, but you don't get any confidence. Think about that if you just giving a testing task to your intern or a junior developer, right? That's what we typically do. Anyway, so that's about the quality. So only good tests make sense. And the other thing is that if you do test automation, then you will, maybe not for unit tests, but a little bit more complex tests, then you will quickly realize that the test automation is a difficult job. So it's not easy. And even if you are underestimating that. And when I was thinking about that, or when I'm talking about that to people, I really like to use this picture. That's one of my favorite pictures. This picture is from 1977, same time when the design patterns was mentioned. And this is about something called approach and landing test for the Space Shuttle program. So what you can see here is that to be able to test the Space Shuttle, they had to build, or at least modify, a Boeing 747 just to be able to test the landing and approaching thing. Okay, so which means to me that this is not simple scripting. This is smartness. This is creativity. This is ingenuity or something like that. So actually, if we can say that, that at that time in 1977 they have introduced something which we now call a stub, right? That's a stub that is a practice that we are also using for testing. So test automation is difficult, and we have seen that the test has to be in good quality, and of course there are many different quality aspects, but maybe two of them I would like to highlight is that we would like to have fast response, so we would like to have the tests are quickly returning some value, and the other is that we would like to keep these tests for a longer time, so maintainability is also a very important aspect, but there are a couple of others. But what we can see is that because it is difficult, it is needing more time and effort, and you need some sort of expertise to be able to address those things. So that's what I had to learn with sometimes with painful lessons. Many people say, and how many of you have heard about that test automation should be first-class citizen? Have you heard that phrase? Okay. A couple of you did. I also heard that phrase, and this is a kind of phrase that you hear that, yes, sure, of course it has to be first-class citizen. It has to be at the same quality as the production code. But then we stop here and don't think behind that. But let's think behind it. What does it mean to be a first-class citizen, the same quality standards than the production code? What kind of quality criteria, or what kind of ways do we ensure the quality for the production code? Probably we are doing many other things, but maybe we are applying some coding standards, right, for production code. Maybe we are doing some reviews, right? And also we are also using tests for the production code to be able to ensure its quality, and many other things probably, right? So that all of these things we would need to apply for test automation code as well if we really want to say that this is a first-class citizen. And that sometimes runs into some interesting problems, like how we want to test the tests, right? Because if you say that this is a first-class citizen, that means that we need to make a test for the test. However, the test for the test is also first class, so we need to make a test that is testing the test, and of course, making a test that is testing the test, that is testing the test, and so on, right? So that's a kind of funny recursion here, right? I don't want to leave you with this infinite recursion for today. Obviously, there is a solution for that, which is which we are typically doing. We are typically applying exploratory testing for our test. Many testing schools says, for example, TDD, that you should see your test failing first and only after move forward, right? By seeing the test first failing, that's basically a way how you have tested whether the test is able to catch some error. So that's what we are doing. That's, whenever you do a TDD, and especially the red part of that, then basically you are testing your test. Okay, so these are the things related to some of the challenges that I have seen for test automation solution. So let's see how the design patterns could help. And maybe so far, what I said was all the bad news, right? Because it turned out that we have to make quality tests. We cannot just put it to the interns. It turns out that it takes time. You need some expertise, so that makes cost. So that's all bad news. But fortunately, there is also good news. And actually, this is also good news, which is important for us for applying the design patterns as well. Because it looks like that tests are typically composed of, I haven't found a better phrase for that, some sort of usual tasks. Okay, so there are more commonly usual tasks that maybe in the production software development. So this is a picture from one of my favorite movies, The Usual Suspects. So probably you also know many of such usual tasks, so I was just bringing up some examples that you see what I'm talking about, so that maybe for many complex automated tests, you have to reset the database to some sort of known baseline, right? You have to use it in many testing solutions, or maybe in many testing solutions, you need to invoke something and just store the results so that you can make some verification on that afterwards, or maybe you are querying the state of the system to be able to make some assertions on that. So these are all typical tasks, and of course there could be more specific and more general tasks in that. But many of the test automation work is related to this kind of usual suspects or usual tasks that we see here. And actually, if this is really like that, then that's a good news for us for the design patterns, because that means that if we are finding a good pattern that is solving a common problem, that was the definition of the design pattern itself, then basically, since there are these usual tasks are more commonly appearing, actually the impact of the benefits of these patterns are even higher than for normal production code. Okay. Again, just to give you some illustration, when I was preparing for the talk, I was thinking about that how many solutions I have seen for this resetting the database to some good baseline thing. And I just found 8 of them which I have used personally, at least in one project. So, and probably there are even more, right? So I don't want to go through them. These are just examples. But you can imagine that these are not necessarily complex things, just like the design patterns are not necessarily complex. Just think about the singleton pattern. But if you know them, or especially if you have a list of them, or if you have a book of them, then it's much easier to apply them, and it's much easier to choose what kind of solution we would like to use for that particular problem. So that's where I said that applying design patterns is maybe even more beneficial than it was with the production code. Okay, so in the remaining part of the presentation, I would like to mention some examples, or not necessarily examples, but some characteristics of these test automation patterns that I have seen. And maybe a few of them will be a little bit more specific, a few of them will be more generic, but I hope that they will be somewhat inspiring for you. And the first thing that I would like to mention, and this will sound a little bit weird maybe in the beginning, but at least for me this was helping a lot about how we should structure test automation code and how we should think about test automation code. It's going to be the UI analogy. I will tell you in a second what it is. But before I go there, I would like to ask you that how many of you have heard about, or maybe they used, any of these architectural models like the onion architecture or hexagonal architecture? Many hands up. Very good, very good. I think these kind of architectural models were probably the most important for me in my software development career. So for those who are not familiar with these, definitely go and Google for them. They are super important. But the concept of all of these architectural models are that normally we are imagining, or at least visualizing an architecture in some sort of layers which are just underneath each other. And in a simple application, typically it works in a way that the database is at the bottom, the user interface is at the top, and many things are in between, right? And that kind of visualization is somehow showing that basically the thing that you have in the bottom has nothing to do with the thing that you have at the top. Okay? However, this kind of architectural models, like the ones you see, are putting the things into some sort of circles, where in the middle of the circle is your domain model. And all the layers are around that. And when you do that, at the end, what you have at the surface are your external interfaces. And if you do that, you will realize that the database is an external interface. The user interface is also an external interface, so they are structurally not different from each other. Of course, sometimes the behavior of them might be different, but they are similar from the structural point of view, which is very, very useful, because if you find some good idea that works for the database, for accessing the database, maybe you could think about whether it also works for the user interface, or maybe some other external interfaces that you need to deal with. So it's a very thought-provoking thing. Good thing. But for testing, what is even more important, that following that kind of thinking, you will see that the tests are nothing else, just another external interface of your application. Okay? So think about that, and especially they are very analogous to the user interface. So that think about what you are doing in a user interface. You are poking with a button, you see some result, right? That's a user interface. What you are doing with a test, you are running a test. The test is making some call to the system on the test, and then you get back a result that is passing or failing. So in many ways, your tests are working similarly to a user interface. It's a very, very weird thing, but once you get used to that, you will see that this is just another interface of your application, how you can communicate with your backend. So actually, these two things are very similar, and that's a good news, because for user interface, we have a couple of good knowledge out there, right? So that there are different patterns out there, there are different knowledge, and those things can be reused also for test automation as well. Just need to slightly adapt that. So a lot of similarities. As I mentioned, both of them are active interface, so you can just invoke something and see some result. In many cases, they are asynchronous and event-based, just like the user interface. Interestingly, both the user interface and the test have a simple structure. In user interface, even though that maybe in a visual it looks really cool, but actually it's only sequencing and composition that makes the structure of that. The tests are the same. You have a sequence, sometimes you have a composite step, but that's the main structural elements for that. And also very important, and I will come back to that a little bit later, that both the user interface are a composition of several different concerns. That's what the MVC pattern is basically designing for. So you have a view concern, control concern, and this is also similar for testing as well. As I said, I will come back to that a little bit later. So that's definitely something that was helping me a lot to think about how patterns could be imagined and how we could apply them. The second thing that I wanna highlight, that for when you are talking about design patterns, we have the Gov book, which is listing, I don't know, 20 design patterns. And typically, we are not inventing a new design pattern every day, because actually this repeating nature is not so much for production code. But for test automation code, it's much more composed of this repeating task or usual tasks. And therefore, you are much likely able to invent your own design pattern that is working at least in your project. So I think in test automation, it's very important to think about how you can find and discover some project-specific patterns. So, and this comes from this high reusability of these usual tasks. And having these project-specific patterns are very useful because, first of all, they are easy to develop. You don't have to make it general. It should just make in your project. It will be obviously much easier to document because maybe you don't even need to really document it. You just need to make a sample solution and have a link to that if you want to see how we have solved this particular problem in this project, look at this method or look at this test, and you will see a good example of that. But of course, besides we will see many project-specific patterns, obviously some of the patterns are going to be making sense as a larger scale. And that's what you can also put in, even if you don't publish that, it will become your tool belt, so it will be increasing your test automation skills that you can definitely be able to reuse in another project or in another company if you are up to that. So that's also a very important thing that test automation patterns are not only done by the gang of four, but you can do your own test automation patterns. And typically, even within a project, they pay off. How you are doing that is a very simple process. I just put it up with a certain bubbles. So typically, there are basically two ways how you can find and discover these patterns. One is that you are identifying a repeating task, and then you just basically designing or developing a test automation pattern for that. That's one way. But I think the more typical way is that you are not even aware that this is a repeating task, but you have to watch that feeling that where you feel that you would need to copy-paste something, then instead of copy-pasting, probably you are just extracting the thing into a pattern, and this is how the initial steps are made to be able to have a project-specific pattern. And the rest is usually the same. So obviously, you need to make a little bit of probing for that, see whether it really works for all the other occasions of the repeating task. Maybe at some points you want to document that. Maybe, as I said, this documentation can be just as simple as having a list somewhere with a pointer of where you can find the thing. And then, obviously, you can apply the pattern and apply it again and again and again and again. And that's a simple process. And in this process, what you can see that I have altogether 6 bubbles which are related to developing the patterns, and only one for the applying. But actually, if you see the actual usage, then all the developing bubbles you only need to do once, and then the reusability comes well. And you can also see that for these developing things is where the most of the complexity sits. So designing and developing a design pattern is something which is a little bit more complex task. And I think maybe, I don't know how about in your company, some of the companies are simply saying that test automation is a developer job and you don't have a specific tester role, and that's absolutely fine, and that's all lining up with the recognized complexity of test automation and many other things. But in many organizations, still there are some separation of the testing roles and the development roles. And of course, this is partly coming from the history, how the things have happened, but we have to deal with this somehow. I've seen many teams where the testers were just put together into the same team with the developer, but they didn't even talk to each other, so they were working totally independently from each other. And that's a bad thing. And I have seen, and definitely that's not the only choice, but design patterns can also help here, because what we have seen that if the design patterns we imagine somewhere in the middle between the testers and the developers, then we can see that the development or the creation of the pattern itself is probably a job where the skills of an experienced developer is definitely needed. But applying those patterns is something that you can do with less development skills. So, and and that can be also a good foundation of working together, because actually at the end, the design patterns will be part of your shared knowledge. The developers know about that because they were participating in the development of them. The testers know about that because they are reusing that often. So at the end, that's at least one way how you can better encourage collaboration between these two roles, and I think that could be really efficient, and I've seen that to be used in a few companies, and it was really working fine for that. But again, the concept for that is that you need to think in patterns, because if you just give the job to the tests without any programmer help, then probably they will not be able to make the solution in a way how that is fulfilling our requirements. So in the last part, I'd like to just say a few words about how you can document test automation patterns, especially if you want to document them a little bit more detailed than just having a link somewhere in your project. And basically, that's the reason why I'm here in this stage and why I'm talking about that, because with Sebros, we started to make a book project. Actually, we wanted to make a SpecFlow book, not so important. SpecFlow is a BDD tool. And when we started to do the SpecFlow book, we realized that we want to have the initial chapters to describe the BDD concepts. But we have realized that why put it into a SpecFlow book if that makes sense for any other BDD user? So we actually made two separate books for that things. And we were almost jumping into the third book, that finally we make the SpecFlow book. And when we started to think about that, we realized that, well, even though that this is BDD and BDD test automation, there are a lot of test automation knowledge that is independent from the actual tool you are using. It doesn't matter whether you use Cucumber with Java or .NET with SpecFlow or whatever else. That could be extracted for that. And we thought that maybe this, the concept of test automation patterns could be the topic for that. Of course, these are not test automation patterns in general, but for a much more focused topic, test automation patterns with BDD. And this is the book that we are currently working on. And we are at the early stage, and what we were thinking about that, how we are going to write down these patterns. So what kind of documentation we are going to use for those. And we have investigated a couple of different options. Unfortunately, there are not so many books that are describing test automation patterns. Maybe the XUnit pattern book from Mesaros is one of the unique example for that. But yeah, so we had to really see a couple of options. But finally, we just went back to the classic design pattern book and have seen how that is documented. And we were trying to see whether those things make also sense for test automation patterns as well, and it looks like they do. So in the design patterns books, maybe you remember, it is described in a way that it has a name and some initial short summary. Probably the most important thing is a motivation, so that which is showing a concrete situation where the need for this pattern is actually coming up. Then of course the motivation was just one example, and the book is typically listing many other ways or many other situations where this can be applied. It is usually completed with a kind of visual diagram for that, and then the actual behavior of the pattern is relatively small part in the book, which is in this participants and collaboration section, and then there are some implementation notes, and consequences at the end. So that's a good way, and seems to be also a good way for test automation patterns as well. And wanna say just one thing about this diagramming thing, because actually we realized that making a diagram for a test automation pattern was a little bit harder than we expected. And when we were talking about that, actually, at least my view on that this is because of the layering problem that we have typically in test automation. So if you think about the classic design patterns, typically the classic design patterns are always sitting within a single layer. So the entire builder is within one layer of your application. But typically test patterns are not like that. Test patterns are typically connecting different concerns, connecting different aspects of test automation, and being aware of these aspects just like being aware of the different aspects of the user interface, like the view and the control and whatsoever, is very important, and it can really help you not only to design your pattern, but think about your pattern and put it at the right place where it's actually sitting. So just a few examples, what kind of concerns you typically see in a test automation solution. So typically in your tests, even if it's not fully separated, there is a kind of testing goal, so what you want it to test. If you do BDD, that's a little bit easier because it's anyway separated into a separate file, but maybe if you would do a unit test, maybe it's just the name of your method, which is setting your testing goal, so what you want it to do. There is typically a big layer which is containing the testing actions. So what kind of things do we need to do to be able to achieve the goal that we wanted to have? But typically, these actions are not necessarily dealing with all the mechanics of how that particle action has to be executed. So there is some sort of automation layer, or sometimes people are calling them drivers, which are actually knowing how that particle action can be done, and this is a very reusable part. Sometimes this is also connected with some infrastructural code, and of course we have the system under test and some other external dependencies that we need to do in the automation. So these are the concerns that you typically will see in a test automation solution, even if you are not necessarily aware of that. And making them separate and making them clear even to yourself that right now I'm sitting in this place and right now I'm connecting these two, at least for me this was helping a lot to be able to think in design patterns. So basically I'm finished now. I thought that I would like to make some samples also from the book, but actually it's not so easy to put it in slides. If you come to me afterwards, I'm happy to show you. We have made some sample descriptions of a few patterns already in the book, so that you can see. That's, I don't know how much this is visible. You see that the motivation part is pretty long. It's almost 1 page, and I also skipped now from the slides the implementation details. So that was basically, these were the things that I wanted to highlight in today's talk. Maybe these are the key things that I would like you to remember. So design patterns are a useful tool, that only good tests make sense, that it should at the end really be first-class design, and you should really do that, not just say that. Tests are composed of these usual tasks, and therefore applying patterns are super useful there, and you can discover these project-specific patterns that are also help you with the dev-test collaboration, and think about your test from the concerns point of view, and try to find some good analogies to finally get your pattern. So last slide, last message. So watch for recurring problems. Try to identify them and try to find time to develop them. Invite the developers, work them together with the devs, or work them together with the testers if you are a dev, and apply the pattern again and again and again. Thank you very much.
Thank you so much, Gáspár. Let's jump to some questions that we have in the Slido. Remember that we use the platform there. This is the platform too. On locally it's yellow, but I hope we can see some questions here. So we have time for two. So the most popular, I will read. The first one: how would you map automate test cases to requirements without requirement specification?
So that's a very, very, very important question, because actually what we really want to have, we want to have requirement coverage, right? But that's something that we cannot measure. We can measure line coverage, but that doesn't mean anything, right? It means, but it's not what we really wanted. We wanted to have that the tests are helping us to know whether we really did what was needed. And there is no perfect solution for that. But what I said, that separating the testing goals, so that being clear what I wanted to test and separate them from what I have tested, is a very good first step for that. And that's what also behavior-driven development is partly about, so that in your feature file, in your scenarios, you're supposed to describe your test goals in a business-readable way. So therefore, you can show that to the product owner and say that this is what I wanted to test. And the product owner can say that, yes, that makes sense, so this test should pass. And somehow this thing is separated then from how you did the test. And that makes the first step of the connection. So that's the quick answer that I was able to do.
Okay, the second one.
Went away.
Can I see the previous slide? This is just disappear.
Anyone remembers what was the question?
Okay, meanwhile, that happened. A minute, please.
Question that whether this is actually a Kevlin honey that we are seeing here, or
Gáspár, in name of the craft things, I would like to give you this.
Thank you very much.
Please help me to open this piece.